This podcast is brought to you by VinZero. VinZero pioneers solutions and services to the AEC and manufacturing industries to support net zero targets. Visit vinzero.com to learn more about how organisations design, build and solve through digitalisation. From VinZero to you, welcome to our Think Future podcast series. Each week we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to VinZero Think Future for access to more episodes, interviews and profiles. Dr. Matthias Irger is an experienced architect, urban designer and academic specialising in regenerative design, holistic city planning and climate adaptation. Matthias graduated in architecture at the Bremen University of Applied Sciences in Germany and holds a PhD in Sustainable Urbanism from the University of New South Wales in Sydney, Australia. As Cox's Head of Sustainability, he oversees the practice's sustainable design and planning agenda, creating its national strategies, objectives and actions to reduce and mitigate embodied and operational carbon emissions across its services, ensuring best practice design. He is actively engaged in bridging science and design practices through his role as Senior Research Fellow and Industry Advisor at the University of New South Wales, and joins the conversation today to share with us the importance of designing for livability. Welcome to the program, Matthias.
Thank you very much for having me.
Matthias, you originally studied architecture in Germany and are now the National Head of Sustainability for Cox Architecture. Can you share a little of your global journey across the built environment to date?
My pleasure. My architecture degree required us to complete an internship in an architectural office to gain work experience. So I decided back then to do this in Australia and come to Sydney for a year and travel a bit before I go back to Germany to complete my degree. And then I got a job offer at Helmut Jahn's office in Chicago. And I moved to the US before I came back to Sydney to work at Cox. It was in 2004. And after a few years, I went to Lippmann to work on the first 6-star Green Star office building. It was 8 Shipley Square in collaboration with Roger Stirk, Harbour and Partners. And that project was really pushing the boundaries in terms of sustainability in Australia at the time, and it made me realize how far behind we were here compared to Europe or the US. And climate change was on nobody's agenda back then, and to implement sustainable design was really an uphill battle. So I went back to university to study sustainable urbanism at UNSW and find out more about how architects and planners can help mitigate and adapt to climate change. Then I spent a few years teaching before I returned back to the architecture industry. And with a couple of detours, I came back to Cox.
And so at university, you undertook a PhD in the effect of urban form on the urban microclimate. Why was that of particular interest for you?
Global heating will make our cities substantially hotter, and it will have profound impacts on how we operate and move through our cities and live in our cities. At 35 degrees Celsius, outdoor activities start to cease. At 45 degrees, it's outright dangerous to be outside. And climate change will make these very hot days much more frequent. And we know that some places in our cities are substantially hotter than others, and we call this the urban heat island effect. The hotter it gets, the more air conditioning we will use, so energy consumption will go up, which will make it even harder to get to net zero. And how do we move around the city when it is 45 degrees? We can't get from A to B anymore, really. And I wanted to understand how we can preserve the livability of our cities and make sure they function in a hotter world with new extremes as well. So what exactly are the drivers that dictate urban temperatures at a local scale and create those heat islands? What can architects and urban designers and planners do to mitigate urban heat and create cool islands instead? So I used high-resolution airborne remote sensing to collect a number of data sets at the same time. That includes LiDAR to get the 3D information on the urban form, hyperspectral data to identify vegetation and materials and albedos or reflectivity, infrared imagery to get surface temperature, and ground sensors to get air temperature. And I found that streets can have more than 10 degrees temperature difference within a few hundred meters, depending on the density, tree canopy, materiality, and proportion of vegetation versus paved areas. And all these factors can be influenced by design and planning. So effectively, reducing urban temperatures is down to the architects and planners to mitigate that. So they are quite powerful in being able to influence the temperature in cities.
So the research obviously was able to quantify and substantiate the need then to think differently about our urban design. So can you explain how it is we need to think differently?
Yes, the most important factor is shade by trees to protect people and the ground from solar radiation and also provide evaporative cooling. The second factor is urban density. When density is very high, tall buildings provide lots of shade during the day but also trap heat and pollution. When density is very low, we have a high degree of exposure, and thermal mass, such as roads, for example, stores too much heat, so cities heat up during the day. The sweet spot in Australia from a heat perspective seems to be medium density around 4 to 6 stories. And the last two factors are materiality and imperviousness. The darker the materials, the more sun they absorb, and the hotter gets the surface and the hotter gets the city. And the less soft landscaping we integrate, the less water is in the environment and the lower the evaporative cooling. So in order to mitigate urban heat, we need to maximize tree canopy, integrate as much vegetation as possible to keep water longer in the urban environment, which also then improves flood resilience. And we need to reconsider our approach to density and prioritize light-colored materials.
So how do you best illustrate the damage of poor urban design on the climate?
Well, as the population grows, we increase urban density in inner city areas as well as in the outer suburbs, as we try to fit more dwellings per hectare basically at the expense of landscape areas. Instead of building up, in the outer suburbs, we simply reduced plot sizes, which resulted in the disappearance of the backyard and outdoor landscape areas. Most recent suburbs are almost completely sealed, with a distinct lack of trees and landscaping and only a tiny strip of land between the buildings. The houses are so close to each other, and the air conditioners in some instances are even facing each other to blow hot air from one unit onto the next unit, and then, of course, increasing energy intake or uptake. Often dark metal roofs and fencing are used, which substantially increases the heat load. And in fact, you would be hard-pressed to design a precinct that would be hotter than some of those new developments if you had to. And this has consequences for the wider city downstream as well. Heat gets transported across the city and makes other places hotter than they otherwise would be. And because of the high degree of sealed surfaces, the precinct contributes to flash flooding downstream. So these precincts are amongst the most vulnerable to the impacts of climate change and have also a very high energy demand, which is a problem as we transition to the net zero economy. So we simply cannot continue down the road and create places that will not be livable or resilient in the future climate.
So those urban heat islands that you're talking about or referring to there with those types of designs, what's the impact on surrounding suburbs?
The urban heat island increases local temperatures by even up to 10 degrees. From one street to the next, you can have huge temperature differences. And that build-up locally in that precinct creates something called a hot air plume. So if you have winds that blow across your precinct, they distribute this extra hot air across the wider city. So precincts downstream can be 3, 4, 5 degrees hotter as well, being affected by the stored up heat in those suburbs. So whatever happens, let's say in Western Sydney, affects also the northern beaches if the wind is right. And in addition to that, in Australia or in Sydney, we often have heat waves that occur when we have very hot, strong westerly winds. And they pick up even more heated up air in the western suburbs and then make the whole kind of experience of extreme heat worse for the rest of the city as well.
That's quite incredible. So where and how can we make the changes required at scale to build better so that we avoid that type of heat upon heat?
I think one of the most interesting areas we have to think about is density. If density is too low and increases heat during the day, we can increase density. If density is too high, on the other hand, it will trap too much heat. So finding the missing middle, as we talk in architecture often about, is one of the key ingredients. Then in the space between buildings, we need to integrate as much vegetation as possible. And the main reason for this is, of course, through trees, we can shade people, we can shade the thermal mass in streets, so the urban environment doesn't heat up as much. Of course, we have other co-benefits, for example, for native biodiversity and creating habitat as well for trees. The other most important factor would be the ground surface. we need to reduce impervious areas and we need to increase green areas and soft landscape areas. The drier an urban environment is, the quicker it heats up, because the portion of energy that is normally used for evaporation is then converted directly into heat and thermal storage. And we need to, on a bigger scale, we need to also then look at streets and how we connect our precincts to increase as much public transport and active transport as well as possible to reduce transport emissions as well.
So do you see a role for policy or regulation to support the planting of trees and the increasing of green back into the urban environment?
Absolutely. Currently, we are operating a little bit in a vacuum and leaving councils to do all the heavy lifting and figure out how we can improve the microclimate, but also carbon abatements or carbon emissions within precincts. So there's definitely a role for a state government or even federal government to step in this space. And particularly if we look at tree canopies, we can't really focus only on a single precinct. As I explained before, the air moves around even past imaginary boundaries. So we have to have a more holistic and larger scale approach. And there's definitely room for regulations, for example, in mandating lighter colored materials for roofs. There's some cities in the world already mandate that you either have to have a green roof or white roof, for example, Paris or New York as well. So you're not allowed to use dark materials anymore. That would make a big difference. But in terms of tree planting, there's definitely a role to establish tree canopy targets. We have to think on a city-wide scale, and we have to also consider other additional green spaces, public areas, streets, basically all areas where we can add trees as well and look at that in a wider city scale.
So there seems to be many areas for improvement in the sustainable design for the built environment and urbanisation. What is it that concerns you the most?
My biggest concern is that in Australia, we are about 10 years behind, let's say, efforts in Europe. So we're catching up quickly, and which is fantastic, but it also presents a lot of difficulties for us architects and designers in terms of regulation as well. Regulation has to catch up. Often we would like to design greener, and the regulations don't support this. So we have to argue our sustainability case with the clients in terms of long-term gains versus short-term expenditure. So I think my biggest concern is if we look at the embodied carbon of our buildings, is that we don't really have the materials available at the moment to quickly transition to a zero carbon environment or reduce our carbon footprint substantially of buildings. Many of the greenest products, so to speak, are produced in Europe, and we don't really want to import those and cause all this additional transport miles to ship them to Australia. But sometimes even that stacks up because green products are just not readily available in Australia. I think awareness is probably the most important factor, actually more important than availability of materials, that architects really understand what they design and understand the impact of the lines that they draw. So, for example, your decision-making when designing a building has the biggest impact, of course, when you select for materials. It's obvious, you select either high carbon materials or lower carbon materials, but also around structure and particularly around when you zoom out on the scale, systems thinking in terms of cities, how cities operate and how materials, electricity and water flows, where it is produced and where it's been taken up and how people move through the city. So there's a lot of, say, inefficiencies at the moment in our cities. People live too far from the center, too far from their job. In Australia, we don't have an excellent public transport just yet. We're working on this, of course, and improving that. But if we look at the whole of economy approach, we are not having all the ingredients there yet at the moment and understanding it either to get to the target that we need to get to very quickly and to implement that, and at the speed required. I think that's one of our major concerns. Education, so we need to train our students better in the universities to bring new knowledge and new technology into the established offices. There are many more new tools available, for example, to optimize your design, and we call that computational optimization, for example, improving your carbon footprint or reducing your waste, aspects like this. These new technologies need to find their way into the average or common kind of architecture office as well and be accessible to those people too.
Are you looking for a digitalisation and net zero partner to help you achieve your goals? Join the thousands of AEC and manufacturing customers globally who have turned to VinZero to start their journey toward a net zero future. With 32 offices around the world, VinZero can connect you to the right technologies and workflow processes so you can maintain your competitive position and increase profitability. VinZero has an industry expert to help you navigate the best pathway forward, wherever you are on your digitalisation and net zero journey. Visit vinzero.com to find out more. Well, let's talk about Cox specifically and how it is bringing together sustainable design through its projects. What are you seeing there?
Cox has a very strong history in sustainability. In fact, when Philip Cox established the practice 60 years ago this year, he was very much putting an emphasis on designing with nature, using natural materials and creating projects that last the test of time. Let's say durable materials, craftsmanship, expression of structure, and minimizing the quantity of materials that were necessary to produce something, to do the job, to create a fantastic environment. So we are very well placed in the context of reducing the carbon footprint, because it is something that is, we would say, it's in our genes. It is one of our leitmotifs to do more with less. That is one of our guiding principles. And therefore, we focus very strongly on increasing efficiency of structure and really using the absolute minimum amount of materials, of high carbon intensive materials, such as steel, for example. And we try to integrate as much natural materials as possible. In general, we try to design for deconstructibility because you have to think about what happens to the building afterwards as well. So if you can take it apart again, you can then separate it into the different waste streams and you have a higher rate of recycling. So we try to avoid composite materials and things that you can't take apart. We try to utilize a lot of recycled or reclaimed materials. We have a number of projects where we were quite successful. For example, the Port Eden Welcome Center, where the majority of the building is made out of reclaimed wood from railway bridges, for example, locally sourced as well. So we try to focus a lot on the impact of the building over its whole lifetime. And on the other hand, we also try to integrate as much nature as possible. Put an emphasis on biophilic design, inviting plants and nature into the building and kind of blur the boundaries between the building and the surrounding areas. That has a lot of health benefits, as well as actually improving the microclimate around the building and then reducing temperatures and therefore reducing energy consumption. So at the end of the day, it's all connected. And what I really try to emphasize here is that every line that an architect draws is really important and has an influence on the carbon footprint. You have to think about in a small detail, at this very smallest scale, you have to think about how things come together and can be taken apart again. You specify materials, so you have direct impact on the actual carbon footprint of the material that you've chosen as well. And of course, before you really, in the beginning of the design phase, you really want to focus on passive design and understanding the site and climate. Cox signals to architects declare climate and biodiversity emergency, and we have very ambitious targets towards reducing our own carbon footprint, our operational carbon footprint, as well as the studio, as much as the footprint of our projects as well. We are now moving from what we previously called sustainability to regenerative design. So really, it's about creating a positive legacy and positive benefits in all areas, let's say, of the project. And that would include, energy, water, carbon, biodiversity, and social culture as well. So we really emphasize on our projects for the designs to give more than they take. We want to leave a positive legacy to contribute to the environment and society. Now, it's really important to understand, since Cox was established, we designed many cutting-edge buildings in terms of sustainability. And one of those projects is, for example, the Sustainable Building Research Center at the University of Wollongong, which was the first building in Australia to achieve full living building certification. And it's still the only building to do so. And that is now 10 years ago. Over those 10 years, there was no additional living building being designed. And now there are more than 25 buildings at the moment in the pipeline to achieve living building certification. So that is very encouraging, and you can see how the industry is moving towards net zero carbon as well.
So what are a few of the multidisciplinary design aspects required to effectively deliver urban design for our future?
I think the most important thing to realize when we design our cities is that we have to recognize the co-benefits and the interconnectedness between different systems. For example, we can't design a city without landscaping because, as we talked about before, it will get too hot, but it will also make for an environment where we don't invite nature, we don't support native biodiversity, and it will have a negative effect on our mental health as well. So I think landscape is one of the most important ones. Of course, we have transport. Transport is the next biggest item in terms of carbon emissions, and urban design enables or precludes active transport, let's say. So if it's too hot, we can't move. If it's not safe, people don't ride the bike. If we have to share a road with trucks, you will not send your kids to school on their bike. So we really have to think about how we connect our destinations, let's say, for example, school, sports, living, working, in a way that allows for, let's say, carbon or reduced carbon travel, more sustainable travel, active transport. The next item would be also we have to look at our energy distribution. At the moment, we are producing energy quite far away on the outskirts of the city or further away, and we use transmission lines to bring it to every house. And why can't we reverse this kind of scenario and produce in every house more energy than the house needs, and then send the energy back to produce hydrogen and start the new green economy, which needs a lot more energy that we can provide.
So your work in quantifying the effects of low and high density design as part of your PhD demonstrated the value of data, you said in the beginning, in terms of building a better world. What do we most need to be doing with the data? How can data help us design out waste and improve urbanisation?
Data is incredibly important to make the case for any sustainable development. We can look at data to create the evidence that we need to implement certain strategies. For example, when we talk to our clients and we require a more upfront investment in order to save energy in the long term, that's when we need data. We can model energy consumption, we can model even temperature on the streets, we can model the behavior of people under different scenarios as well. And we need to utilize the power of this modeling and predictive capacity, let's say, of data to inform our design, to test our new designs and to optimize those designs. That, I think, is a lot of reason for hope. Some people may be concerned that AI arrives and what the impacts will be for architects. I see it as a huge opportunity to assist us to just improve our urban environments, improve our projects and buildings, really test what we designed there, if it's going to work, and importantly, how it will perform under climate change scenarios. So if we look into the future, we are looking at a lot of uncertainty, but we also don't really understand the consequences as yet. So if you talk to people and say, okay, we have 1.5 or 2 degrees climate change, many people think, oh, that doesn't sound too bad. But we forget that it's an average of an average, and that the manifestation of that climate change in the local neighborhood may be 10 or 12 degrees or many times flooding a year. So we have to really look as a society, as well as from a social equity point of view, how we deal with those, ever increasing extreme events, be it bushfires, be it large-scale flooding, or be it many, many days of extreme heat. How do we cities operate, and what can we really do to mitigate that? And data and AI will help us by verifying and by testing our ideas and helping us also to develop new ways of dealing with these new challenges.
So it's a great segue to my last question, which I always like to ask, because you've mentioned there in that answer the word future many times. And I always like to end our conversation by asking people like yourself, when you consider all the great things that are going on in the built environment at the moment and all the opportunities we have to improve where we're at right now, what is it that excites you the most?
Australia has always been a land of opportunity. We have all the resources we need to create a truly sustainable society. We have food, we have sun, we have water. Yes, it is misplaced and not available during the rest of the year and not at all times in the quantities that we may need it, but we can manage it. It is over the year, it is available. So I think with technological advances, for example, AI, data collection and so forth, we can really plan better for the future. We have the resources. What we're lacking is effective and long-term planning that takes also all the risks and livability of all things. Of course, livability is the most important in respect of climate change into account and improves that and safeguards this. I think we now have to move to the next stage in terms of future planning to safeguard the great, experiences that we have in our cities here. Architects and planners are perfectly placed to drive the change that we need to transition to a zero carbon economy. Right? We are used to deal with difficulties, regulations, and balance all different kinds of needs of society, the client, and with outcomes for the public and the urban realm. So we are perfectly placed to on the nexus of decision making to improve, the legacy and include climate change requirements and so forth. So I'm very hopeful. We understand what needs to be done. We are developing tools to help us do what we need to do. And I think the awareness that something needs to be done and to be done differently is now apparent to everyone. So I'm quite hopeful that we can now move to a stage where we try to fix things and avoid increasing our climate risk further.
Certainly, we're very lucky to have an organisation with such a strong history in sustainable design as Cox Architects, and we thank you for coming on the program and sharing your insights. We look forward to hearing more from you in the future.
Thank you so much for having me.
This podcast was brought to you by VinZero. VinZero help the AEC and manufacturing industries keep pace with digital change and achieve their technological and sustainability leadership goals. VinZero is a company that cares about creating and building a better world. Together, we are working with industry and environmental experts, providing forums and platforms through our VinZero Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community. Like and subscribe to Think Future to stay up to date with the latest innovations and conversations as we take AEC and manufacturing around the world closer to zero. You can download our podcasts at vinzero.com or from your favourite podcast platform. From VinZero Think Future, thanks for listening.